Okay, so this will be question number 3 from the sample IB exam from paper 1. So this one has to do with composition of functions, and then also one about finding an inverse. And again, I guess it's easy for me to say, but I think this one should be relatively straightforward. So we have a function from the set of real numbers to the set of real numbers, and that's what you're going to be working with in this exam anyway. And those are defined by f of x equaling 2x plus 1. We've got g of x equals 3x minus 2. And then in part A, we have to do f composed with g of x, then g composed with f of x. And lastly, we'll find the inverse of simply the function f of x. No inverses of the function g of x that we have to worry about. So, okay, part A. So recall that f composed with g of x, all that simply means is, again, well, I'm going to say it again, it's f of g of x. And all that means is everywhere there's an x in our function f of x, we're going to put everywhere there's an x, we're going to put g of x. We're going to replace those x's with the function g of x. Well, in this case, right, for f of x, there's only one x. So we're going to substitute in that function g of x in just one spot. So, okay, so again, I'm going to rewrite it. We have f. What is our function g of x? Well, it's 3x minus 2. That's what we're given. And again, I'm just going to replace this x right here with that function g of x. So we'll have 2. And now instead of multiplying by x, we're going to multiply by 3x minus 2. And we still have our plus 1 that we have to tack on there. So, and now it's just a matter of simplification, right? If we distribute, 2 times 3x is going to be 6x. 2 minus 2 will be negative 4. And then we simply add 1. So we're going to be left with 6x minus 3. That'll be our solution. Part B, same idea. Now we have g composed with f of x. Well, okay, that's g of f of x. And we know that f of x was 2x plus 1. So now we're going to do the same thing. Everywhere there's an x in our function g of x, we're simply going to plug our other function into there. So I'm just going to replace that x with the function 2x plus 1. So we're going to have 3 multiplied by 2x plus 1. And just like before, let's not forget about our minus 2 left over. Okay, so not too bad here. 3 multiplied by 2x is going to be 6x. We've got to distribute here. 3 multiplied by positive 1 will be positive 3. We've got our negative 2 left over. So hey, we're going to be left with 6x plus 1. And again, notice in general that these functions, when you do multiplication, right, it doesn't matter the order that you multiply. Don't get this symbol confused with multiplication, because composition, well, clearly is not multiplication. And in general, when you do things in a different order, as we see here, we did f composed with g and then g composed with f, well, we got 2 different answers. So don't just think you can, what you get for one, you're going to get for the other. Last but not least, we need to find the inverse function. So f of x is equal to 2x plus 1. So recall what you can do here is we'll just replace the f of x with a y. So we have y equals 2x plus 1. Now, every place we see a y, okay, there's only one. Everywhere we see a y, we're going to replace it with an x. And everywhere we see an x, well, again, there's only one present here, we're going to replace that with a y. And now we simply have to solve for y, which means move everything over except for the y. So I'm going to start off by subtracting 1 from both sides. So I would be left with x minus 1 equals 2y. So again, just subtracting 1. And now I'm just going to either divide both sides by 2 or equivalently multiply both sides by 1/2. So I can multiply by 1/2, multiply by 1/2. And okay, there's 2 different ways you could write this, right? We could distribute and write 1/2 x minus 1/2. Or you could also write it as x minus 1 divided by 2. Either of those are great. And once you have y by itself, that's now your inverse function. So we've actually found the inverse. Easy peasy, no big problem. So x minus 1 divided by 2, that's going to be equal to our inverse function. And yeah, that's all there is to it.